everyone. Please take your seats. We need all participants to take their seats as we will be starting shortly. Everyone, please take your seats. Thank you.
All right. 2023 ICPC World Finals Challenge powered by Huawei. First, I have a few announcements to make, and they are related to the input and output. So a couple of you didn't really receive a lunchbox. So please note that we are out of, and maybe you were ordering that option. If not, please don't worry. You will be approached individually and you will be offered a choice of whatever is left out of the options. The second one, if you need to go to the restroom, so verbally, it will be towards the 47 World Finals and opposite direction from the spectators. If you are looking at me right now, here is the visual option that way. So that's where the restroom is. And moreover, to highlight that co-coaches and coaches can attend this event as well, but their position will be in the restaurant. So we are ready to start. So in this ICPC challenge, all teams, their coaches and also co-coaches are working on a single problem. This problem is brought by Huawei, and we are trying to find the most optimal solution. This challenge is inspired by real problems. So these great challenges that Huawei is working on right now. And it's my great pleasure to introduce the first guest from Huawei, who is Bill McCo, the director of the Computing Systems Lab, Zurich Research Lab, Huawei. So Bill, if you are here, please come on stage.
Thank you. Well, first of all, it's a great pleasure to have the opportunity to speak to this amazing audience. So they asked me to say a few words before you get going. I'm delighted to do that. So what do I want to say? So computing and AI are revolutionizing the world today. The world has many problems, many challenges, and there's probably never been a better time to be a talented programmer. The world really needs you. So with that, I want to say something about the challenges the world is facing today in computing. I can get that slide. Okay. So let's get started. So I'm going to talk mainly about computing and AI in terms of the speed that we need and the scale that we need to solve today's problems and future problems. Doing that, I just want to say something about Huawei. So Huawei, as you know, is a global technology company, one of the biggest in the world. And as a company, we are driven by research and innovation. We produce as products and services pretty much everything in the whole stack of computing. We produce chips, CPUs, AI accelerators. We produce clusters of AI accelerators, enterprise and storage systems, cloud services, of course, smartphones, and also, of course, we're the world leader in communications, 5G, 5.5G, going on to 6G. And we're also a major developer of key open source software for phones and servers, databases, and AI platforms. So everything today in AI is shifting from traditional CPU-based computing to new AI compute. And we're in the forefront of developments both in hardware and software for these areas. Here's an image of one of our large-scale AI superclusters. So these can have thousands, indeed tens of thousands of very powerful AI accelerators to tackle the biggest problems in AI today and in the future. Also, in terms of our relationships with the broader community, Huawei is one of the world's foremost investors in R&D, as you see from this chart produced by the European Union. So Huawei invests more in R&D than companies like Apple or Samsung or Intel. So we're in the forefront of investing in R&D. Within Europe, which is where I'm based, we have around 25 different European research centers spread all over the continent. So I'm based in the Zurich Research Center in Switzerland. So in these research centers, of course, we undertake a lot of basic fundamental research. We do product-related long-term research. And we also work very closely with leading universities and professors. So we fund professors, their projects. We fund postdocs, PhD students, and interns. And we see this as critical to Huawei being a major player in the global technology and research ecosystem. And we're growing rapidly in all of these areas. So if you're attached to a university, we'd love you to join us and work with us. Just as we're sponsoring this contest, we also sponsor and fund all kinds of research activity. So I said I was going to talk about some of the challenges. So I want to just share a few slides to give you an idea of what AI computing looks like today. So kind of starting point is, how do we get speed in computing? So a lot of you think a lot about this challenge, and there's basically only three ways. You can change your hardware. So for example, as you all know, if you change from one CPU type to another, it may produce something like 10x improvement to the performance. But if you switch, if you're doing AI and you switch from a CPU to a dedicated AI accelerator, you can maybe get 100 times improvement in speed. But it's not just hardware, of course. You can change the software. So there's well-documented evidence that if you take a standard computing problem and you just write the solution in Python, it won't typically be too efficient. But if you work hard to highly optimize it, say using C, using all of the facilities that you have in modern multi-core CPUs and use them to best advantage, you may be able to get 1,000 times improvement, and this is well documented. But of course, it's not just hardware and software. Perhaps the most important thing is if you can find a way to improve the algorithm. So if you're looking at a problem in AI, which is, say, requiring at the moment n-squared operation, But of course, the computational problems being tackled are huge. Trillion parameter large language models. So today in 2024, the training of an LLM can require as much as 10 to the 25 operations. This is today, and this kind of number is growing. It's such a huge number that it's hard to understand it in any way other than mathematically. It's 10 trillion. And this is what people are doing today. So suppose you want to get into AI training today and you realize maybe buying So suppose you want to get into AI training today and you realize maybe buying a whole cluster of accelerators to tackle the problem. So suppose you decide to buy 100. Well, today a system of that scale would cost a few $1,000,000. But it's really not very usable problem of that scale because 100 accelerators, this would take more than 8 years. So suppose you up the budget, say, to 1,000. Well, that certainly helps. It costs you now maybe $20 to $30 million, but it still takes almost a year to do this computation. So really, the game today, as you, I'm sure, have read about, is to go to really huge numbers of accelerators. This is what all of the leading players are doing. So when you get to something like 10,000 accelerators, which might cost you today several $100 million, then you can do this. You can train LLMs in 1 or 2 months. So that's the situation today. So I'm focused here on LLM training, which is perhaps the most written about application today. But it's not just training. In fact, what's called LLM inference may actually be even more demanding in compute power because there will be much more of it done. So here's a nice quote on LLM inference, this emerging, very important application of computing. And it says basically, as a lot of people do, that LLM inference will probably largely replace what we used to do and still do with search engines. But it's very important to note that a search, for example, on any of the standard search engines costs very little in terms of compute. It's very cheap. But if you were to replace it by an LLM inference, then those are not cheap. Those are actually extremely costly relative to doing something simple like search. So this is a nice quote that says that if we go down this path based on today's technology, today's hardware, software, and algorithms, then if for a single country, it may require more energy than a whole country. So this is why the world needs talented programmers like yourselves, people who can improve algorithms and software, and maybe also hardware in order to make a breakthrough here. So we do have good evidence, again, that this should be possible. So here's a statistic in one area, image recognition, which was a very hot topic, say, 10 years ago. So between 2012 and 2021, it's estimated that through algorithmic improvement alone, same software, same hardware, same problem, that better algorithms were able to deliver around 16,000 times improvement. So that's really worth having. That means that the energy and cost involved will go down correspondingly. So just to close, so what are key technology areas for future AI and computing? Well, they're what I described. We need much better algorithms, we need much better software, and we need better hardware as well. So just to say something about the challenges that a research center or research lab, such as the one I lead in Zurich within Huawei, is considering. So the first point to make is that today computing is cheap. That is, arithmetic is cheap. For decades, in the early part of the development of, indeed up until probably 10 or 15 years ago, arithmetic was largely what people focused on. But today, this is no longer the case. Arithmetic is cheap. Computing is cheap. But everything else is expensive. It's very expensive to move data, to store data, and to move data between machines. So memory bandwidth, communication bandwidth, memory, these are all much more important than arithmetic in improving efficiency. And the good news for AI is that there are other changes happening in AI that were not typically in other areas of computing. For example, low precision. You don't need to have 64-bit numbers to do AI. You can sometimes just use 8-bit numbers or even 4-bit numbers. So improving algorithms is maybe the most important thing in order to impact the world for future AI. But we also need better software as well. We need new programming models. We need new compilers. We need new tools for mapping and scheduling. And those will also play a very important part. And then finally, it's not that we're at the end of the road for hardware. We're really just beginning there as well. Today we have GPUs and AI accelerators, which are certainly far superior to CPUs for doing AI. But there's much more to be done. We can accelerate a lot more than we currently do. But equally well, it's very important that our system architectures are optimized for memory bandwidth and bandwidth. So those are just some of the problems that we're focused on in Zurich. As I say, other labs, other centers are working in other areas. I've just tried to give you a glimpse of some of the topics that we're interested in and working on today. So with that, thank you, and have a great contest, and enjoy the Huawei Challenge.
Bill, thank you so much for an inspirational talk. It was a pleasure to have you here. And as I'm standing here, I'm getting more and more announcements to make. So some of you might like to perform on an empty stomach, but if you want, you can start to eat now, because once we start the challenge, you might not have time to eat. Anyways, I have another interesting person who is our guest from Huawei, and he's one of the co-authors of the challenge that we will have today. And in fact, he was one of you a few years ago, so he was competing in this competition as well. So it's my great pleasure to invite Lin Chang, the software expert on wireless in the business unit at Huawei. Please come on stage.
Okay. Hi.
Thank you.
Thank you. Okay. Hi, everyone. So it's my honor to be here to introduce the ICPC challenge powered by Huawei. Okay, that's the background of the Huawei challenge competition. So the first carrier aggregation in LTE is a critical technology that provides higher data transmission rates and improve user experience while increasing network capacity and flexibility. This technology can allow users employ not one but two carriers simultaneously. One will be the primary carrier for the user, and the other serve as a secondary carrier. So what we can see from the figure, so the carrier 1, carrier 3 will have two directional relationships. So the carrier 1 has 10 users as a primary carrier, and carrier 3 has 5 users for the primary carrier. So further, carriers can be divided into clusters called carrier groups. Inside this group, certain joint scheduling algorithms will be used for better performance, but there are some limits. First, the maximum size of the carrier group is limited, and the carrier can only be grouped in one group. So in this test, what we need to do is to maximize the total number of users included in each carrier group. And the users will be counted only if both carriers are in the same group. Then, moving on to the input and output. So we have 4 inputs. The first one is N is the number of carriers. M is the number of directional edges. P is the maximum carriers per group. And then the M lines with detailed information about directional edges. So you can see from the standard input, so we have the first line 5, 7, and 3. 5 is the carrier's number, the number of carriers. So we can see we have carrier 1 to 5. And then the number of directional edges, we have 7 lines overall. And also the maximum carriers per group is 3. And then we have following 7 lines with detailed information about directional edges. The first number is the primary carrier, so the carrier 1. The second number is the carrier 3, and what we have is 10 users. So this is the input. So the output is the total number of satisfied users. So what we got, and this one is related to the final score. And then the number of carrier groups and the detailed information about the carrier groups. So what we have from standard output, the 48 is the overall users from the carrier group 1 and group 2. And 2 is the number of groups, what we have. And then the second line is the number of carrier groups. The first group has 3 carriers, carrier 1, carrier 3, and carrier 5. And the second carrier group has 2, carrier 2, and carrier 4. So that's input and output. That's very simple. Okay. Then, in regard to the scoring criteria, the solution score is calculated as follows. So we have baseline partition in which UB users are satisfied. So if you output an invalid partitions, you will get a 0 point. But if you output a valid partitions in which U users are satisfied, your score will be counted by these 2 formulas. If the satisfied users between 0 and double UB, the following formula will be like this. So it is totally linearly related to the satisfied users. So if your users are more than double UB, you use this following formula. So it will be less extra reward if you get a very high score. So the final score is based on the weight of the specific test case. Every test will be allocated a weight for each test case. So the final score for this test case will be P multiplied by weight and divided by 100. So note, there's a note in a field test, the baseline score UB is very close to the optima. So in such test, your score can't be too high based on this preceding formula. So if you meet this situation, please just don't be hesitant and move on to the other test cases. So the finally is information about test case. So the overall, we have 50 test cases, 25 for open test and 25 for secret test. So the main parameters and scoring weight of each open test will be provided. So although the secret test will not be provided, but they are very similar to the open one. The total score for the contest is the sum of the score for the two parts. Each part may only submit for testing no more than once every 10 minutes. So please organize your time wisely. So the score is the best of the score, not the final. I hope all of you will enjoy this contest. Okay, thank you.
Thank you, Lin Chang.
Thank you.
Okay, so we are almost ready to start the challenge. However, I have been asked by the ICPC technical director to share a few instructions. So you can see the countdown, and I will try to speak fast so that we get it handled. So as the airline says, your safety is our primary concern, and in the unlikely event of an emergency requiring the tent to be evacuated, please follow the followings. All spectators, including coaches, will exit via the 4 doors behind you. The 46 teams will exit by going towards the spectator area and then going to the left, down to the exit space. The World Finals 47th teams, marshals directing you in which direction to go in case this unlikely thing to happen. All right. We are excited about it. Or can I ask again? Are you ready to start? Oh, that was much better. But you can take everything that is under your keyboard, open the envelope, and you will have 3 printouts of the specific assignment for this challenge. And I hope you have a great ICPC challenge.
Hi everyone, welcome to the commentary session of the ICPC Challenge of ICPC World Finals Luxor. I'm Lydia Perovskaya, ICPC Live Director, and together with me I have one of my wonderful ICPC Live teammates, Azat Ismailov. Hi Azat, how are you?
Hi, hello. Yeah, it's been a complicated day for us, but...
You will be with us today. We will try to give you all kinds of fun information. Currently you see that we have 1 minute 54 seconds of challenge remaining. A long time, and so it is very important for everyone to get a nice cup of tea or get some coffee, because it will be quite a few minutes until we see a first incredible people to this broadcast. We'll have interviews with both problem author as well as ICPC alumni, Huawei employees, of course. We'll talk about wonderful opportunities that Huawei presents. For more information, because after the end of ICPC challenge, you will have an opportunity to solve a problem very shortly, and in the meantime, get a cup of coffee.
See you!
Hi everyone, and we are back with our first wonderful guest to the broadcast. Those of you who are frequent at the ICPC live broadcast and have watched Challenge broadcast from last year as well as ICPC World Finals last year absolutely know, but for the rest of us, please meet Rafael. Rafael, so happy to have you here again.
I'm happy to be here again.
Rafael is not just a Huawei employee, but what is in my opinion more important, obviously a part of ICPC community, being an ICPC World Finalist in the past yourself. Can you tell us a little bit about your ICPC experience?
So I started ICPC on my first year of undergraduation actually. So like from the very beginning I was already like trying to be part of it. And then like I started with a team, trying to like understand like how the community works. And then every year I would participate in the ICPC and slowly get better and better until at my 4th year, I guess, I managed to get into the World Finals. And yeah.
This is an incredible experience. When were your World Finals? Where have you participated?
So I participated in the 2019 World Finals in Porto, Portugal.
Nice, nice. This was a beautiful World Finals. I highly recommend watching a live broadcast of that World Finals because it's a lot of fun. It was a lot of drama.
Really cool.
That was very exciting. And now, what brings you back to ICPC? Well, obviously, Huawei is one of the core partners for this ICPC. Indeed, our diamond sponsor. And Huawei has so many initiatives in the area of competitive programming. Is it also something that you do as part of your daily job? Do you ever organize programming competitions or attend programming competitions as part of your job?
So it is kind of a, how should I put it nicely, or like how to put it, well explained, like, so it started because since I went from ICPC to Huawei, they already knew from the beginning that I had an interest in that. And then when they started organizing stuff, the people who are organizing said, okay, do you want to go? And I was like, of course I do. So
Everyone wants to go,
yeah,
right?
little by little, I started getting more and more into the community, participating more and more, and that's kind of how it started. So whenever there's like an event or anything ICPC related, I'm always there, at least like maybe on the background, but I'm somehow in the like staff, I guess.
Which event so far was the most exciting for you? The one that you attended from the ICPC or other competitive programming events as well?
I mean, I have to say my first World Finals, I mean, kind of basic, I suppose, but you know, it's really nice, like the first time that you like are part of it and really like the first experience and like really like seeing how it is. And like, I don't know, like the first like touching the environment, it's such a nice, I don't know how to explain, like a really nice first contact.
Right.
And it really motivates me to continue more and more, so.
Well, first World Finals are definitely a special experience. I can absolutely agree on that. It was unforgettable. The first World Finals happened for me in 2012, which is, as we counted, is precisely 10 World Finals ago.
Wow,
And,
congratulations.
And the cool thing is we have a lot of people for whom 2012 was a significant year here at this World Finals. Some of them are coaching, some of them are here as alumni speakers and as alumni, so it's very fun to see so many people coming back to ICPC over all these years, just like you. And you've also had a lot of experience in looking at ICPC from different perspectives now.
Yeah,
so not
definitely.
just as a contestant, but also as a partner representative, and also you helped with finalizing the problem for this challenge. What were the most different things in your experience by changing the sites? And dear spectators and dear contestants who will watch this broadcast in the future, you are always welcome in the community in any quality that you think is appropriate, as in it's very obvious that top contestants can turn into brilliant judges, as well as brilliant technical team members, maybe commentators, hosts. So absolutely stay in touch with the community and see how can we work together in the future. But how was your different experience over the years?
How should I best put it? Like, I guess probably the first big thing that I noticed of difference is like understanding like how big really is like the support that's going behind. So like you're aware that there's a live, etc. But then when you are part of it, you realize, oh, there's like this many people working on this. There's this part, that part, And the second thing, I guess, is like the whole problem setting of it. It's such an interesting experience, I suppose. Like being the one like doing the test and like trying it, doing the context, and being the one who is trying to prepare for those people. It's, I don't know, such a different like experience, and try to like figure out, okay, this sounds interesting. Should we do like harder? Should we do it simpler? How should we like balance everything and make something really interesting and cool for everyone?
How do you feel about this year's challenge problem? I think it's a very, very fun and interesting one. Once again, dear spectators, you will be able to participate in a challenge based on this problem in the future. It will be open. For today, though, it's just for our wonderful contestants and coaches, attendees in general. So, do you think, are you happy with how problem turned out this year?
Yeah, I'm quite happy actually.
Cool.
It's a very interesting challenge because we organize it so that there is an easier way that you can like focus on more simple problems and some of the harder ones. So, for example, we divided all the test cases into an open set and a secret set.
Yeah,
so
let me show it to our spectators in a form of a scoreboard table. So we have problem A1 and we have problem A2. And we have many more submissions on A2 than on A1. Does that mean that A2 is specifically problem with open tests and A1 is something that is closed?
I'm not 100% sure on that, on how they decided to merge it. I assume so, but I'm not sure. Yeah,
Do you think it's easier to approach a problem with open tests than
definitely.
the one with closed test data? Oh, hi.
Oh, cool.
Now we have light. Now you'll be able to see us better. Oh, let me show you how we look with this wonderful lighting conditions. Yay! Hi everyone. Yeah, much
cool.
better. Thank you so much.
Thank you.
Which of the problems did you personally enjoy more? The open test sub-problem or a closed test sub-problem?
I kind of like both in a way. So like, first like to look at the open tests and try to like figure out how to do them, and then think, okay, if I do not know like exactly the test, how would I try to adapt it? So I guess like this transition from one to the other would be the part that I find like really interesting.
So are scores for both of the sub-problems equal in a sense? So is there max, well, obviously we have an optimization problem, so it's still something that you should not achieve the perfect score ever in, but are theoretical perfect scores comparable and equal, or is one problem more important than the other in your opinion?
So we try to balance both of them so that they will have equal scores. So one of the like main things in the setting of the problem was to make sure that the number of hard challenges in the open set and the secret set were similar, the number of more easier problems were similar, and so on. So it's more or less of a balanced set. So if you have like a good idea that you think open for the open ones, then once you try on the secret ones, you should also have a nice solution.
Okay, okay. When you were solving this problem, have you started with a solution that works on open and then adapted it to a closed one? Or would you, like, you know, for a little secrecy, even though you start with an open problem, decide to not submit and hold your solution until you have a proper solution for closed test one as well?
So I think like probably the very first step that I would do is to try and like get the easiest problems in the open set and make sure that I have a good solution for all of them. After that, I would probably like try to look at the difficult problems. Once I have something that looks really good on that, I would probably submit to both at the same time.
Okay, that's fun. Personally, when I follow programming competitions, I always actively dislike that approach, even though I absolutely understand why for contestants it's actually optimal. You don't want to give any extra information out to your competitors, right? You want to make sure that everything, they think their score is good, but your score is actually better. But at the same time, from a fan perspective, so annoying. I'm always so nervous about the teams that I'm rooting for, specifically because they often hold off submissions, and so you don't know the real result. So,
but that's the thing. It's so nice to have the drama, you know.
Absolutely, absolutely. Okay, I just want to introduce a few more concepts so you know that today we have scoreboard is split into two problems, one of them A1 and another one A2. They are roughly scored with the same number of points, which does not mean that scores cannot go higher and much higher for one problem than the other, but still. And another important point in my opinion is that we actually have two different scopes of competition. Currently in our corner of the screen, you see teams working in the team area as teams of three. So we actually have our teams competing together against each other in a team competition like this. If you look at the scoreboard and you see teams that start with 46 or 47, it means that you actually are looking at a scoreboard of teams. Not distinct contestants, but specifically teams. As usual, 46 represents teams that are in 46th World Finals and 47 represents teams that are in 47th World Finals. So if you see multiple lines with exactly the same university name, but one starts with 47 and another starts with 46, this is fine. This is not a typo. This is exactly how it's supposed to be. Welcome to ICPC World Finals Luxor. Yeah. Double the teams, double the fun, as we say it. But then we can switch to something that we call a coach scoreboard. It's not precisely coaches though, because actually co-coaches are also allowed to participate, team guests. Well, theoretically, everyone who is registered with a team for ICPC World Finals Luxor and came here on site. Logins and passwords were only distributed on site. You can see that there are a few challenge spares here and there. During the contest, they will change names into specific identification names. We hope that it happens as soon as possible. And you can also absolutely see that coaches are much lazier than teams, which is probably to be expected because teams came here, they worked hard to be on this World Finals, so they're ready to rock. They're ready, they're focused, they're so in. Whereas coaches, if you saw our registration broadcast or maybe some pictures from official photo gallery, well, you know how beautiful it is here in Luxor. And well, probably more coaches decided to opt for a pool than for a challenge, which is shame on them, but absolutely understandable.
Yes, indeed.
We have, for each coach, we have a university that they represent marked in parentheses. And just for your reference, we have a common leaderboard that shows everyone on a same page. But once again, it's very easy for you to identify if these are teams or if these are coaches. And the numbers of places that you will see in scoreboards are from this joint scoreboard. But we will actually have separate awards for teams and for coaches, because obviously coaches are participating solo and teams are participating as a team of three, but with one computer. But coach theoretically can use multiple computers for whatever reasons they actually need. So a lot of different options. Please do not get confused. I hope that as we repeat it through the broadcast, you'll see that it actually makes sense and it will be fun for you to follow. Okie dokie. Going back to our wonderful common leaderboard, we can see a lot of very different scores. Some teams have like literally ones of points as their scores, and our leaders in the meantime, let me bring them up, are over 5,000 points already by the sum of two problems.
Yes.
What score is good and what score is bad? How do you feel about it? What is the baseline solution? What should we look forward to? And maybe you're ready to bet what score will be somewhere within the top 10 by the end of the contest here.
So I don't think I can give you anything too specific regarding the score.
Okay.
But I would like to say that we are going in the right direction. I think the progress that the teams are doing is going in the correct path. And maybe soon we have something that is really perhaps closer to the maximum, perhaps.
Okay.
Let's see.
So we are close, even though we are just 40 minutes into the contest.
Well, I didn't say we're close. I say we're heading there.
Okay, okay. Direction, not velocity.
Yes,
That's
exactly.
fair. That's fair. Let's keep it at this. Once again, we'll introduce you to the problem during the contest. We'll just have a little more time to chat about it. In the meantime, I know that you have some exciting new projects you're working on
Yes.
in Huawei. Can you tell us a little bit about your current projects, current team?
Sure. So I'm at Huawei as an industrial PhD student, which means that I work on research, and the research that I do inside the company becomes a published paper, which also helps me get a PhD in a university in the same city as I am.
Oh, where it is? Which university are you currently
I'm in
graduating?
Germany now, in Dresden, with the Technical University of Dresden.
Are they present at the World Finals as one of the teams?
Unfortunately not.
So you're the real representative for University of Dresden here.
Yes,
Good job, good
indeed.
job.
And one of the things that I'm kind of progressing in is trying to like really put something that a research that can be both applied in the industry, but also have a really nice academic result. So I want to kind of merge this idea of a nice theory or a nice idea, but also something that like can be useful and be a real product that could help the world and have new solutions.
Sounds great. Can you tell us a little bit more about your specific research?
Okay.
What's the state of the art now?
So I'm working in the research for operating systems in general, more specifically in the area of concurrency. So I work on large-scale servers where you had hundreds of CPUs, and you have programs that are running with all of those, and you need to somehow make sure that these programs run as fast as possible. So it's kind of an extension of ICPC, but instead of focusing on algorithms, I'm focusing on the concurrency part. And my project is in trying to improve both some algorithms like spin locks, but also some operating system components such as scheduling as well. So I'm trying to push all of the boundaries that I can do to get more and more performance out of these systems.
Is it just concurrency or distributed computation as well?
Currently, I'm mostly focusing on concurrency for what is called NUMA systems, non-uniform memory architectures. If for those who maybe are not too familiar, it's basically the new model that most like large-scale servers are using. So it's maybe distributed systems will be like the next step, but we're still heading there, I guess.
That's fair enough. Throughout the history of programming competitions, we actually had events where contestants were asked to solve problem not using this classic approach of competitive programming, where you have essentially one kernel that implements, that executes your code, and you have to calculate the time that this specific kernel spends on the solution. But instead, well, I was specifically asking about distributed because one of the examples was specifically for distributed problems as well. But do you see that there is a possibility of having a type of programming competition where solutions are actually executed on NUMA systems?
I would certainly enjoy it very much. I think it's a really nice area, and there's definitely like nice solutions that we can have and a really nice contest. So I'm definitely interested if someone is interested in collaborating and starting something like that, and it would be a really nice opportunity, I suppose.
Cool, cool. We are always looking for new formats, new ideas. As you know, interactive problems recently reached ICPC World Finals, so I think that as a next step, we can absolutely have something that will be completely brand new format for our contestant, but also very close, because a lot of scheduling specifically is, well, algorithms, right?
Yeah, of course.
When was the last time you saw a proper scheduling problem on a classic competitive programming competition? Has that ever happened in your competitive career?
Yes, it has. I have seen, like, probably the last one was the last Huawei challenge, I think. But when I was competing as well, there were like several different competitions which usually they focus on one specific aspect of scheduling and trying to get a good algorithm for that specific piece of it. And it's always like a very like recurring idea and like solution, because it really is something that algorithms really should be applied, and it really makes a lot of sense.
Oh, sure, absolutely. Which way did it go? Have you seen your first scheduling problem on programming competition and then went into research in that area? Or was it like, oh, is a problem that's right up my alley. Let me solve it. It will take just a minute.
No. I think it was more on the first side. Like both scheduling problems in ICPC and just ICPC as a whole, like really pushed me to go into this research area because I really like always have like new challenges and like I discover something, I managed to do it really well, but wait, there's another thing that I haven't even tried and that it's being even more challenges. And because of that, I kind of went into research, and of course, I chose an area that I could apply some algorithms, but at the same time, it was something that had a lot of things that I had not learned yet. So this whole part about concurrency and like really trying like multiple threads, multiple processes, was something that I had to like learn much more deeply in my PhD now.
Cool. How do we learn about your research? Is there a way to follow you on social media or to find what you're currently working at somewhere in the internet?
So most of the works that have been published are, I think, in my LinkedIn and also in the company website. So if you look for the Huawei Dresden Research Center, where I'm located, there is a list of the papers that we have published and what are the topics that we are studying. So that will be, I think, the easiest method, I suppose.
Okay, sounds excellent. Because it's very important to have the clear opportunities and options,
yes.
because it's not always just industrial engineering. It's often pure computer science research and applied engineering and applied informatics research and algorithms as well, both in industry and in academia. And it's very fun to have, well, professional scientists as part of our ICPC community. That's very exciting. You also had a lot of roles through your ICPC volunteering career as well.
Yes, I did.
Because last year, and I hope this year as well, you're joining as an ICPC analyst.
Indeed,
Right?
I am.
So everyone will see probably either in the live broadcast or in problem analysis videos, or definitely will receive your insider information from here. Oh, we actually have a new best result from Tsinghua University on problem A1. They're now 5,646. The increase is not by much. They've just increased by 4 points. But every time you see this green pip on the right to their to the submission page, this means that this is an improvement. And well, Tsinghua is currently Tsinghua 47 is currently leading. This is, let me tell you, a pretty competitive team as well.
Yes, indeed.
So you did live broadcasts, you did analysts, you are one of the people on the judging team for challenge. I think that absolutely everyone who helped make the problem as good as it is part of the judging team. You were a contestant. What are your coaching plans and what are your RCD plans?
So currently the only coaching plan that I have fixed was as a pseudocode for my team in my previous university. So they came here, but unfortunately the coach could not be. So I'm the stand-up coach apparently. So, but I'm still not sure about the future, what it will hold. And for RCD, we'll see. Maybe we should have a bit more contact, talk a bit more about that.
Well, I think that with the involvement that we have together, with you personally, with wonderful Huawei initiatives throughout ICPC, we would be very happy to see you in all the possible future roles at the World Finals. If you have anything to address our spectators, absolutely let us know, because we'll be moving on to our next guest shortly. So any wishes to our spectators currently following ICPC Challenge?
Well, I wish you all to really enjoy and be part of this environment and really like learn a little bit about it more and experience it. And we hope to see you like in the next lives, maybe in the next World Finals. And you're always to be part of the community here.
Absolutely. Thank you very much for coming. It's a pleasure to have you here, and see you, well, tomorrow.
Yeah, see you tomorrow. It's a pleasure to be here.
Hi everyone, and we are back, and now I'm with a very special, for me personally, guest, a person who I've seen from my very first years within the ICPC community. Please meet Sergey Belov, now representative of Huawei, but a person with one of the longer ICPC histories in the whole World Final stuff of this year.
Oh, thank you, Lydia. Thank you very much for kind introduction, and glad to be here and glad to see you. You know, long time no see.
Right.
Glad to be here again, and you know, I really miss this, you know, opportunity to discuss with ICPC community, to see students, coaches, everyone. So yeah, thank you.
It's great to have you back. Tell us a little bit about your career at this point. What are you doing now at Huawei as a technical cooperation manager?
Yeah, well, I joined Huawei about 4 years ago, and I'm responsible for technical planning and technical cooperation in Huawei Cloud. This is one of the core business for Huawei. We have very strong R&D capability either in HQ but also in Russia. So I'm very happy to help the team and to grow, to become more mature and contribute to the company results. Yeah.
That's so cool. Well, you obviously have an outstanding understanding of how competitive world works inside out. Do you work with competitive programmers on a daily basis, either as some of your colleagues are ICPC alums, or are some of your projects specifically focused on competitive community?
Oh yeah. In two ways, you know, when you trying to get in the leading industry positions, you clearly need to understand what the cutting edge is all about. And if we talk, for example, about software, I mean, cloud is not only about software. But for example, let's talk for a second about software. Basically, one wise guy once told that software company is just people and the way you organize them. So basically, a lot of depends on people, and bright people make the future. And it does not mean that it's very easy to work and easy to find and easy to make to work in a smooth way and make. But clearly, it's the only way to get competitive advantage over others, for sure.
Right. ICPC has a long history of challenges. In the past, there was Java Challenge, where all contestants were invited to write, basically AI agents. Well, back then we did not call them like this, but they indeed were AI agents that were acting against each other, usually playing a computer game or something interactive. And then we had so many years now of optimizational problems. Do you think some of those are, at this point of our industry, are more important as directions of your actual education? I mean, obviously, you need to know algorithms and data structures. If someone wants to tell me that you don't need to know algorithms and data structures now that we have Devin and AI and LLMs, well, I will be ready to fight you in the comments, so absolutely let me know. But do you think moving into this like actor model or into optimizational algorithms that are more applied is more important?
Well, it's to me this kind of a personal flavor. For me, for example, I very much enjoy, for example, seeing the robots play each other. I still remember, and you know, and definitely ICPC audience enjoys this as well. And and I also kind of believe that it's not the last time we see that here. That's my prediction. From another hand, now it's like, you know, I would say in rough terms, it's kind of now we are facing kind of NP hard world, and to get some clue how some of those most challenging problems be solved, it's good just to give them to the brightest mind and see what's happened.
Right, absolutely. It's very nice to be able to pull problems from the industry, but also this is why I think Huawei is uniquely positioned to provide these problems year after year. unsurprisingly, World Finals is not the only place where ICPC Challenge hosted and powered by Huawei happens. So for example, this year Latin America Championship also had ICPC Challenge powered by Huawei. And it's very interesting how there are so many different domains that you can pull problems from, and they are still, as a result, parts of the same, problem infrastructure. Ultimately, we are still doing the submit your solution that will be evaluated by a checker program, and you will get a feedback on how well did you perform. Do you think there is something unique for that? Like why is it possible to pull from so many different domains into such a similar framework at the end?
Yeah, but it's just a framework. It's like it's like if you're going to a very early school education, and somebody like your teacher is teaching you how to write, this is given, this is to be, but basically even the framework is the same, the solution, the problem might be kind of different here.
Right.
And another point is basically, for example, if we talk about Huawei Cloud only, we have teams doing, basically everything, starting from infrastructure and scheduling, going up to software and then to applications. And if you're talking about R&D, I always say it's like sometimes more R than D. And when you decompose the problem, it's, you're going back to mathematics. It doesn't mean that after you decompose the problem, it's becoming much easier to solve. But that at least we can offer that to wider audience. Wider in terms of those who can understand what the problem is. It does not mean that basically it's easy to solve. But no, it looks the same. The problem are different. I know some teams who basically develop these challenges. This is the research teams. That, for example, in Huawei we have algorithm innovation lab, for example, and some problems are coming from these teams, and they clearly understand what the industry is working on, what research problem industry is working on, and also to make a little bit, I would say, entertaining for students here to work. And I know that Huawei problem are known for their simplicity, I would say. I would say like that, joking a little bit. But I believe it's at the end it's a good and challenging problem, I think.
Cool. Can you tell us a little bit about, not existing specifically challenge problems from the domain of cloud computing, but probably what are the interesting directions that we may see some problems from in the future? We can give a small hint. Once again, I'm pretty sure that we'll see many more ICPC challenges powered by Huawei in the future, and I'm very much looking forward to some coming from your teams as well.
Oh, it's not that easy to predict at this point, but I would bet on some problem related, to, which stems from large language models, how to make this efficient, how to as like machine learning oriented problem, because basically looks like it has a bright future. Quite few series so far many people are working on, and still some very nice programmers, trick and engineering tricks still working. I believe this might be a good direction. But once again, talking about Huawei Cloud, we have the whole stack basically, from infrastructure to software and to applications, and regardless where you're going, for example, to compressing the video, it's still a lot of challenge and problem, and how to make the optimal compression, how to provide the best quality video. I'm talking about just one application,
sure.
But if you talk about trends, at least for now, it looks like for several years from now, we will have large language models to show the good application, which would be really working in some industries, but somebody needs to develop, and teams are working on that now.
Oh yes, that's a lot of work. People tend to forget that that's actually a lot of work. Daojan Buketov asks, is there a mirror contest? There will be, not a mirror contest, but rather a marathon version of this problem, so stay tuned. You can look up the announcement on Code Forces on ICPC news page to see what are the wonderful prizes that are in stock for those who are not at the World Finals on site today, but will be able to compete very shortly. So definitely a lot of fun possibilities are coming. But then going back to LLMs, I was looking forward to one of my guests touching up on this matter because during ICPC Challenge, our contestants have access to the internet. Whereas usually during official ICPC events, you're not allowed to access internet. You only can use your pre-written source code that's called team reference document, which is, well, the whole internet compressed into 25 pieces of paper with a reasonably large font while we're on it. So once again, large language models. Do you think that existing state of large language models and assistance of any kinds are actually helpful enough so that it can give significant advantage at Huawei Challenge here today?
Well, no, I'm not an expert, I would say, but my bet would be not at this stage. Not at this stage yet, and we still need to rely on our own brain.
Problem's too hard, right?
I mean, getting the plausible answer doesn't mean getting the right answer. And I mean, if you want to tackle the challenging problem like our contestant facing, I don't think, and there was an attempt to solve, to train the system and to solve some simple problem, but it's yet a long way to succeed.
Great. Let's take a second to look at our best teams currently. So our top 20 looks like this. We have National Research University Higher School of Economics from 46th World Finals in the first place. And this is, well, Higher School of Economics turns out to be a challenge powerhouse, because I hope I'm not mistaken, but I think they were also in a top position last year in Dhaka. We have ETH Zurich, Nanjing University, University of Warsaw, Seoul National University, Peking University, and Tsinghua University. And then we have a first top coach in 8th position, but once again, do not forget that coaches participate individually, whereas teams participate as teams of 3, but still are only allowed to use one computer. So there is actually not much, well, advantage, I'd say, for teams over coaches. Then we have International IT University, one of co-coaches. We are currently exploring who specifically it is, so you'll see it updated in the scoreboard. Xi'an Jiaotong University, University of Tokyo, and then another coach from Harbor Space University, Barcelona campus, Kamil Dybowski. And in general, in the first page of scoreboard, we only have like a few coaches, probably 4. Unfortunately, coaches are not too eager to participate. What a huge mistake. Let's look at the coach scoreboard specifically. Here we go. Here are the top 25 coaches on the first page. We have a very nice diversity of universities, but definitely not all of our registered coaches are actively trying to solve the problem, even though we see that teams are actually much better at doing the problem, because out of the top 100, there's just a handful of coaches within them, whereas many teams. Does that mean that the problem is so approachable, literally every student can start solving it just within an hour?
Well, this is kind of a tricky question. Basically, first of all, it's still a warm-up. And, we need the people to be in a good mood. And by the way, I'm very happy, very glad to see, many known people here, and not many big surprises looking at the team list and the coaches list. And very good to see, I see Andrei Lopatin here, I see Gennady here, that's good. I mean, and people also
familiar faces as well.
Yeah, and I see also Andrei Stankevich here, many familiar faces here. And as for university, we have High School of Economics, we have ETH, also Warsaw University is closed. So I believe it's, we know who will be competing really hard to get something big, good places this year. Well, I don't think that challenge is simple, no way. But it's kind of opens the space for different type of solutions, and we'll see. We'll see. But let's see the results. Actually, it's a lot of intrigue here. I'm very interested to see what's going and who's going to beat everyone.
Currently, leaders are actually packed really close. You have 5,700 for our current leader, National Institute University Higher School of Economics. But then if you look at, well, say place 50, you'll only have 5,300. So the difference is actually not that bad, like within 10%, definitely. And then I'd say almost every team that actively tries to solve the problem is currently at this roughly equal score of 2,400, 2,800 for sub-problems A1 and A2. And surprisingly, a large number of teams are actually sharing their positions, and then they have well, not precisely, but rounded with one character after the dot. They actually have very close scores, which does not mean that they have implemented exactly the same solution. Because even though they are given a baseline, or they have an idea of a baseline, we have so many matches, teams are just implementing pretty similar approaches.
I guess many teams got the essence of the problem and going along the way, the natural way. But having said that, I believe the last mile is most challenging one, and this is, we'll see, real monsters.
Do you think that challenge is, well, first of all, it's very uncharacteristic for optimization contests to be so short? I'd say usually we see contests like this run for, well, a few weeks probably, so that contestants do not only have time to, we have submission from our first place university right here. Let's see if Higher School of Economics can actually improve their submission. So usually contests like this run for a long time, so that you can do your due research into the subject area. Because if you're asked about something that you have never heard about, it may be a little complicated to get a grip on it and to just identify the direction of the problem. Then you want to look at the state-of-the-art papers and read at least, skim at least through of them, and then implement one or two, as we call them, stupid solutions, and then move to something that is actually optimized and algorithmically, well, optimistic.
Well, yeah, basically, obviously, if you have some kind of upfront knowledge, it would be usually helpful. But you know, everybody is in the same position, and the challenge is formulated in very general terms. So it doesn't look like, you know, somebody. You don't need to know quantum theory, hopefully, to come up with the best solution. But having said that, even you formulate the problem in simple and general terms, it's good. But once again, the close result means that teams kind of pick up the essence of the problem and started. And by the way, once again, this is we still want teams a little bit to warm up and to have a feeling of what kind of problem basically coming from industry we are looking for. Maybe people will become interested, and we are more than happy to work with them.
It seems like it's not just a warm-up for our contestants, in here, but also a warm-up for them before the marathon challenge. Well, first of all, because of the incredible prizes, because one of the prizes is actually a trip to the next ICPC World Finals, which in my opinion is just brilliant. But at the same time, you will have more time to work on a problem. You already have this very fundamental understanding that you achieved through 3 hours of, you know, practice and trying and looking back at it. And this is a very nice thing to have. Do you expect your marathon participants to impress you so much that you actually use something that they worked on closer to the production? Obviously, I'm not suggesting deploying right away, but actually looking into the approach direction.
We will see. To me, this requires much more efforts, maybe a little bit different skills, and I believe that the prize will come with some real efforts team to spend to do some. Yes, this if you're talking about marathon, it requires not like, you know, try more and get better, but some real real deep dive in technology, in theory, and probably we can come up some kind of new type of algorithm. And this required a lot of efforts, a lot of devotion. You really need to devote a lot of time to make it happen.
Cool.
But if it's going to be a brilliant solution to get a first prize, I mean, this is obviously will be noticed by a company for sure.
Huawei organizes a lot of competitions. I also follow closely events from Tech Arena brands, Huawei sub-brand, which presents so many interesting, not just challenges as in challenge problems, but also just wonderful set of new opportunities, new problems from industry and real life problems that can be solved as either a part of the internship or any kind of practical applied programs. Have you participated in any of them in the past, and what is your general idea? Is there something that we should specifically highlight out of the Tech Arena initiatives?
Well, honestly speaking, I don't know. To me, my gut feeling is like, you know, there are people who really likes to compete. And for example, when Mike Mirzayanov did this, you know, many years ago, with very small initiative, become, you know, large, really large, and people go in and people contribute tasks, people like to solve them, and basically leveraging this and also getting these people flavor of what kind of industry problem are facing. I believe it's a good way, and I invite everybody to contribute to this, yeah, for sure.
This is incredible. How do you invite more people from the industry to try and propose new problems for competitive events? Because you obviously have this incredible experience within company of so many enthusiastic people joining the whole competitive programming shebang year after year, coming with new and better and more interesting and more diverse problems.
I can't say for the whole company, but from my experience, we have several teams who participated in preparing challenges for ICPC event of different type, and other challenges as well, by the way. We never had a shortage of people, of experts, to think and to submit this problem. You know, people like to solve problems, people like to oppose the problems. That's like, so it's not like, you know, we are forcing people to do this. People are doing this with a great pleasure.
Right. And speaking of challenging problems, it's obviously always a great pleasure when your day job is connected to solving some real life problems that will just make a world a better place. Which problem within cloud domain do you personally consider being the, well, probably not the golden grail of today, but at least something that you personally are the most excited about?
Well, it's if you're talking about problem cloud industry is experienced now, to me, the most challenging part is how you make a real synergy between your hardware and your software to work. And this is like, you know, it's like the overall statement. It's decomposed in many different and very challenging tasks. And by the way, some of those, you know, formulated as challenges, by the way. This is where you can get competitive advantage over your competitors. And basically, you know, with this new large language model coming to the stage, it requires new way of thinking how your hardware works successfully with your software, how to make, you know, some training in realistic time, how to make your inference really deployable on, you know, on client devices, you know, and this is new types of problems. It's not yet well established. Everything is new here, but at the same time very exciting. So yeah, I believe this is where company sees the future, at least from cloud perspective, see its future. And we'll see how it happens.
This sounds incredibly exciting. Thank you very much for a lot of very inspirational content. Anything you want to wish to our spectators and viewers right now? I would be happy to give you an opportunity.
Well, first of all, very glad to see all of you here. And as for challenge, I would just like two things. First, enjoy the competition, and the second, try to solve something by yourself.
Sounds like good luck and have fun, as it's said in competitive esports. Thank you very much for joining us. I'm
you,
very
Lydia.
happy to have you as
Pleasure,
part of
mine.
the ICPC community again.
Thank you, Lydia. Thank you very much.
Hello everyone, welcome back. And I'm now here with a special guest, with ICPC Challenge Director Tomasz Czerny. Tomasz, so great to have you here. How are you doing?
Good, thank you for having me.
Well, first of all, thank you so much for putting this challenge together. I think it is very exciting and the competition is very active currently. We have new leaders, so it's not National Research University Harrow School of Economics anymore, with just less than 10 points advantage over them. In the first place, it's currently Kyoto University from 47th World Finals, and in second place, it's Peking University in 47th World Finals. And if you know Peking University in 47th World Finals, they are ready to rock and roll, definitely. They're one of the favorites for the World Finals themselves, and apparently they're not just good at algorithmic problems, but also at challenge problems as well. This is a very tough competition to organize. Tell us a little more of your stories about the competition.
Well, first of all of this is an ant work, right? So we are a coordinated ants, and I especially would like to thank too many volunteers that are involved in this, and invite all those ex-ICPC finalists that would like to contribute to the community and come up and help us with those challenges. Because yes, Huawei comes up with an interesting problem, but it's typically in a raw format, and we depend on those volunteers to actually test it, be involved in it, maybe add a little bit of flavor of the ICPC to it. And that's pretty much how we do that. It's not really you just sit at the table and you come up with a solution. That is many days that we have to loop through that, right? And especially this and last year, we had many challenges coming out because we have 3 World Finals in 1 year. Mm-hmm. So it's a lot of work, and of course, without you guys who are volunteering, we cannot make this happen. So while I'm the representative of all these, you know, I don't take the credit. I don't do this hard work. It's on them, and it's you ex-ICPCers who have this sort of feeling that yes, you want to contribute. You enjoyed it yourself when you were students, and you want to give it back. Pretty much all the people that are running this competition are those volunteers that simply want to do that for the good of their future peers.
It's wonderful. ICPC alumni community, it feels like they can do it all, but they're specifically good at setting interesting programming competition problems. And
that's for sure.
This year's challenge is definitely one of them. Well, this year is a wrong statement. Luxor one
yes.
is definitely one of them. We'll see what's coming up in Astana in just a few months from now. In between Luxor and Astana, you'll have an opportunity to solve the marathon version of that challenge, to then be probably invited as a guest to the Astana World Finals. So definitely stay tuned to the Code Forces announcement. And at this, there are so many different sites to coordinate. Mm-hmm. There are problem creators and authors, obviously representatives from Huawei, and they want to make sure that whatever problems they have in the real life industry is properly translated into what's next. Then you have Code Forces platform that helps with evaluation process and testing process, but also you need to adapt problems in a manner that works for Code Forces. And also you want to make it interesting for us spectators, and you want to make it helpful and important for future careers of contestants. There are so many criteria to optimize. How do you solve the optimization problem of optimizing those priorities?
That's right. So what I really like about ICPC challenges, you have just one problem, and it's not like you solved it and here's the time limit, you're done, you're passing, right? Like in a regular contest. No, you have to tweak it. You have to make it best out of all those submissions that are there. And yes, it has this beautiful deployment production flavor. But even from Huawei, we have ex-ICPCers, so they're involved in it. But because that problem is really complex, and we have to ensure that when we test it, that we deliver something that can be optimized and it's not solved suddenly to the maximum, right? So it takes time to optimize these problems. We typically come up with a couple of samples that we have, and then we choose those that are the top candidates. So the selection round of having multiple problems on the table is really exciting, because then you are choosing, oh, this could be potentially a really good problem, right? And a lot of problems can be tweaked into something that we see here today. So yes, it involves many people, and you come from the raw perspective into tweaking individual details, into how are we going to score these things. It requires a lot of work.
know what to say.
I'm specifically also very interested in, we already touched that, for example, 47 Peking University is up here at the top. How do you adjust the difficulty of challenge problem so it's challenging? I'm sorry, I cannot stop myself from making stupid puns. So that it's challenging enough for not just our top contestants, but also their coaches who are sometimes, well, even more renowned in competitive programming community.
Well, that's a very good question, but I think that goes a little bit beyond of what I can contribute to it, because I am here to represent the ICPC challenge, not necessarily develop the problem, right? So it is really challenging for the creators as well, and that's why it takes a long time. It's not a thing that we will solve within one day. It takes multiple days, and that's why we have multiple candidates for the final problem set that we would like to have at the World Finals, because then we can ask those testers and volunteers. Those are brilliant ex-ICPCers, and they can tell us how they are solving it. We can see that, right? So in that perspective, yeah, we have the Albert Einstein on the team who is testing it, and then we are trying to find the new Albert Einsteins in this beautiful competition. So we assume that we have those candidates that are the brilliant minds on the testing team. And of course, more testers we could have, better it would be for us to ensure that it would not happen that suddenly all the teams solve that problem with a perfect solution.
Yes, exactly this. Another thing that I would like to mention and then elaborate a little, I absolutely provided incorrect information. So our contestants do not have access to internet this time. So there is no way for them to use any kind of LLM or AI support from the outside. So they still have to essentially do the same that they do at the World Finals. They start with a cleanly installed computer and they have to build it all from the scratch. What is the thought process behind deciding if they're allowed to have internet or not? Does that affect your problem choice, for example?
It definitely does, but I could answer pretty much what these answers from the Albert Einsteins of our team we had. LLM will not help you for those problems. It might give you some initial idea, but yes, if you would have that solution from ChatGPT, you might be solving that problem, but certainly not with the optimized score as those winners. So yeah, maybe having the initial insight will drive you there, but maybe that initial insight is not the right solution. It leads you completely wrong solution. Still think about it. LLM, those ChatGPT models are based on what is out there on the internet. But you know, you cannot have just Google to solve these problems. It's not that easy. And yeah, we will maybe hear from Jacob when he has the speech tomorrow after the award ceremony, and he will say that ChatGPT
Challenge Spears turns out to be Jakub Pachachki working for a problem using any kind of resources they have, but at the same time, it is an original problem. There is no ready solution anywhere in the internet.
That. Hey, maybe next year you should ask Jacob not to come as an alumni, but as a third kind of competitor, where he would have a team of those trained in ChatGPT-4. I think that would be pretty neat experiment.
True, absolutely. Another thing, what programming languages are allowed for our contestants?
Well, I think that there is exactly the same portfolio of languages that we have for the finals. So there is no change in that perspective. Well, code forces might have some restrictions, so it might be better directed to Mike than to me, because he's running the evaluation. So if you have a chance to talk to Mike, he might tell you more of those technical details.
Obviously, Codeforces supports dozens and dozens of different programming languages, but to use them, our contestants will actually, need to have an IDE or probably even run a solution on their own machine, which currently, as they're using World Finals machines and World Finals images, they do not really have access to those extra resources. Do you think this gives an edge to our coaches who can work from their personal laptops? And so, for example, if they don't want to write the solution in C++, they can switch to Rust, whereas our contestants definitely can't.
Yeah, so there are multiple perspectives, right? So why we don't allow the internet is that we don't want them to communicate with someone. And once they would have access to the internet, Well, we cannot enforce that they cannot communicate to someone. Coaches have access to internet, first of all. That's a great advantage because they can talk to someone, but we believe coaches, so that's not that big issue. But yes, they have access to those additional platforms. But on top of that, if they need some specific documentation for that given problem, they can find it online, right? So they have faster access. However, at the same time, we have 3 team members, 3 minds. They can combine that knowledge, and frankly speaking, the students are as smart as the students as a teacher speaking here. So I am very convinced that all students that I have are as smart as I am, and when there are 3 minds next to each other, they're probably going to outsmart the coach. So we'll see at the final results, right? What does the score says right now?
Yeah, sure. Let me refresh the page. We actually have, well, a pretty significant advantage of our contestants over coaches. Currently in the first place is Moscow Institute of Physics and Technology from 47, then Kyoto Peking University, we just mentioned recently, as well as Higher School of Economics, and the top coach is in 10th position. And what a coach! If you look at the scoreboard, that would be Sejin from Massachusetts Institute of Technology, one of the brilliant ICPC alumni and medalists in the past from a team that I personally very much rooted for. Another fun fact is one of Sejin's team members, Li Ji-chen, if I'm correct, is actually actively doing computer science research, as many of other coaches also do, because they are faculty staff and often doing an active research members as well. So it's nice to see them apply all of their skill and knowledge here. I would be very much interested in getting the perspective from teams and coaches sharing their approach. How is the submission process built this year? Do everyone submit their source codes that get run on the server side, or do you only have to submit already a calculated solution to the problem?
So we run everything through code forces, and pretty much the same approach as you would do when you train on code forces. That's totally identical. So pretty much the only thing that we do is we distribute the passwords and the accounts to the students, and then they are running the entire infrastructure. So the data, which is the source code, is coming all the way to the servers for code forces. So
that's great.
We better have the connection.
And it's so great that you actually have access to the source codes, which means that whatever approach was used by contestants, it's stored here in the system, so they can go back to it to improve on their solution. And then, well, in the future, they may be interested in this specific domain and topic, and then continue their research from here. How do you choose a problem domain? I know that you've already mentioned you have multiple problem concepts that you develop for the same year. What do you personally look for in a challenge problem?
Well, that was the hard thing, because I was choosing the challenge problem, right? But we were choosing 2. One that we sacrificed because of the transfer from Sharm el-Sheikh. So that was our original problem that we wanted for the finals. And then, is this going to have a complex input? Will this be something that is not just basing on simple 2 lines that are considered as an input? Are there many variables to consider? Are there many optimization perspectives to it? Is it not just one optimization? So broader it is, of course, better that it is. At the same time, we cannot give students a 10-page document with the specification. So it has to be something that is presentable within few pages. Right now they have 3 pages, so it is pretty much readable. So something concise that still introduces difficulty and has the nice blend of the technical problem. So what do we see there? Optimization within networks. We see there some Turing machines. We could see there other kind of problems where we find the standard algorithms in by default. However, again, you have the multi sense of optimization. So it's not really just applying a single algorithm. You have to apply algorithm to this problem, this subproblem, that another subproblem. So it's difficult to find, because these 6 candidates we have had, they all were very nice problems, and maybe out of those 6 candidates we will be choosing something for the next year, because it's not that easy to choose from those problems. But maybe I would get back here to the coach you know, it's a very marginal difference, right? So it's 5%. So maybe the coach will outperform the teams that we have in here.
Yeah, there is absolutely that possibility. Even though currently Sejin is in 10th place, plenty of time to finish the contest brilliantly, because we have now just crossed 2 hour mark, so 66% of the contest is over. And then I think that this will be the psychological point where everyone who was holding back their solutions, or probably have only submitted problem A2, have now been switching to problem A1. Now it's the time to actually show the cards and figure out how it goes.
Yeah. So looking forward to it, and I like that live experiment while we are comparing the coaches and the students, right? So maybe next year if we compare the AI here, when we have those experts, and you know, you guys are those who are involved in the AI, right? So think about it and feel free to be engaged with your comments and proposals. How can we make it happen to actually make a competition of human versus the AI? I think that would be really brilliant.
Sounds like a very interesting direction to go. If you have any ideas like this, or thoughts, or you want to join the ICPC Challenge team and help us with preparing this exciting problems, absolutely reach out to manager at ICPC Global, any other ICPC Global email. We'll be happy to work with you. And thank you very much for coming to the broadcast and dedicating a few minutes. You know, having a contest director in a commentary booth means that everything is running very smoothly. So congratulations on a brilliant
there
contest.
There is a great team behind me. I don't want to take any credit.
Deal. Thank you very much, and we'll be back soon with you with the next commentary. Thank you.
Thank you.
Hello again, and I'm finally together in the studio with the man himself, Mugi-chan. Hi, great to
Hi.
see you.
Hi.
Can you
I'm
introduce yourself to our spectators?
Okay. I'm Muge, and I was a former ICPC finalist, and currently I'm working for Huawei Data Communication Department, and I'm happy to share today with you guys about the challenge problem provided by Huawei.
Are you the person who was working with the real life problem that you then translated into the challenge problem? Is it right that you do something like this as your day job?
Yes, that's some kind of day job for me because it's important to do some like translation to translate the real world problem to some mathematical problem we can understand like the contestants here today. But to be clarified, I'm not the problem setter for this problem. I used to propose a few challenge problem for Huawei before.
Can you explain to our spectators the general idea of the problem? Because I think as we are now almost 2.5 hours after the problem introduction, maybe some of our spectators have just joined, what the problem is about. If you need a mouse, you're welcome to use it.
So the problem is have a real world background. So it's more like a wireless network. So in the wireless network, like a 4th generation or 5th generation mobile networks. So we have carriers. In one mobile phone, we can connect it to multiple carriers, but we need to divide the carrier so that to maximize the network bandwidth or some performance issue. So in this program, we do some simplification that we need to divide the graph. We model the network as a directed graph, and we need to divide the node is the carrier, and there are some edges. That means we can share users between carriers, and we need to divide the graph to a graph partition into a different part. Each graph with no more than p carriers, and we want to maximize the total user that can be shared among the carriers. That means the sum of the edge weights you can see on the graph. So the background is mostly it's a model about the network performance, but we convert it into a simple mathematical graph partitioning problem. So it's very hard, and it's like I think it's like NP hard or NP complete. So it's a hard problem, hard algorithm problem. I hope the contestant enjoy it and solving it.
This is nice. This problem is split into 2 parts. So when we are selecting problems, this one is the
and A2.
And A1 is the problem where you just submit already calculated answers, and then A2 is the problem where you actually submit the source code, right?
Actually, yes and no. Actually, the participants needed to submit their submission for both programs because the first one we have open tests that the participant can see the input directly, and they can adjust their solution based on the score from question for A1. And the test set for A2 is hidden, so they do not know the input for their program. So it might be much challenging to get a high score for A2. And the problem statements for those 2 programs are the same.
Can you tell us a little bit, and I don't know, this may be a secret, so let me know if it is. How do you prepare tests? Are these tests real life data sanitized appropriately, or is it synthetic data that you created so that there are tricky edge cases?
Yeah, that's a good question. So both we have some edge cases that need to make sure all solutions correct and they can perform well on the extreme cases. But also more importantly, most cases are the real world data. So in the scoring function, there are set we have a weight for the final score. That means for specific test cases, that case is more important because it's important in the real life. So we give the test case higher weights. If you are doing well on this test case, then that means you are doing better in the real world. So different test cases have different weights that based on the frequency in the real world. So most cases are based on the real world, I think.
Okay. Can you talk a little bit about the scoring system that you have? How accurate the scoring is? How much of a real life difference a few hundred points make?
I think real world is very much complex, more complex than this problem. So in my opinion, I will give something like 50 of 100 score to this problem. You know, in the real world, especially in the wireless network, there are not much more things to do. Something about physics, something about networking and algorithm, much more challenging, more than mathematics thing. So I hope more challenger can join Huawei and to solve some hard problem like this even harder. And so the score function and another tip for the scoreboard, you know, in the currently standing board,
we will have to switch a different scoreboard for our spectators to see.
I see.
Here you go. But we can continue looking at the scoreboard that is available also in the description of video. Here we go.
Okay. So the scoreboard here.
Let's refresh the page so it says updated.
So we can see the top teams are already get some score, like the total score about more than 5,700. So from my colleague said, in Huawei, our baseline solution got like 5,000 score, like close to 5,000 score. So I can say most teams are doing well by get a better solution than our baseline. So we are happy to see this, and I hope at the end of the challenge we can say higher score even.
Right. So 5,000 was the baseline score.
Yeah,
is there a theoretical maximum score that can possibly, well, cannot possibly be reached as it's an optimization score? But should we think of 5,000 as 50% of something, or is it just independent?
It's just dependent. I just think if you can get some score above 5,000, it means you are doing better than most programmer in Huawei. You know, so we Huawei have some developers and they are doing well in solve real world problems, and the baseline solutions from them. So if you are doing better that means maybe you are doing, I think is doing better than most people in Huawei now.
Just as a note, even though live broadcast scoreboard usually shows 4 or 5, well, 5 or 6 in this case, meaning characters, in fact, the calculations are in code forces or with higher accuracy. So in case of any ties that you see in a live broadcast, we'll verify the scores down to the, well, at least third digit after the dot. So we'll have higher precision in a real life. But currently we see that there are so many solutions that are really close. If you look at the difference between first and second place, they're currently Moscow Institute of Physics and Technology and Tokyo Institute of Technology. With scores of 5,700, their difference is 5.
Yeah.
Not 50, not 500, just 5.
Yeah.
So this is pretty impressive. They are so close. Do you think it means that they're having pretty similar solutions, or is it just luck?
I think they are likely to have similar solution, and you know, the challenge session currently held is very time limited. They only have like 3 hours to implement their own program to solve this question, so to solve the problem. I believe in later we have an online version that challengers will have some time like 2 weeks to so the challenge, so they can have much more time to implement the solution. When the time is limiting, you have only 3 hours, so the choice is very limited. So that means most contestants will tend to choose a similar solution because you can only write a few code during the session. And also, that's another problem is that because we are presenting our friends with a real-world challenge, that means even in Huawei, we still do not find a best solution to the question. So the best we can do, you can think we can do something like 5,000 or more, 5,500 score, but we don't know the theoretically the best answer we can achieve. So we hope the talent people like the well finalists can achieve better than us, and we hope to share the thoughts for this program to get better network.
Cool. Can you give me a little bit of insight on how is the proper problem preparation process built?
Well,
what do you start with? What are your criteria and important points?
The critical and important. So from Huawei to build a challenge program, the most important thing is that it must be based on real-world program. Unlike in ICPC, most programs are not for real-world background. Maybe they have some background, but most programs are for challenging and for test. There are algorithmic programs, but in Huawei, the challenge program must have some real-world background. That's the first thing. And it needs to be hard because if we are giving you easy program, then it's nothing to do with the program. It's not interesting. So it has to be hard. And both of the two things limited the choice range of the program. So in Huawei, I have a lot of challenging and hard real-world program. But also, we can only solve the problem in 3 hours. Take into the count of you need to read the problem statements to understanding what it's about. So we have some hard problem, real-world hard problem, but you need to first read some several books and for several days to understand, have a clue about what it's about. So it cannot be, this kind of problem cannot be considered into the challenge. So after consideration, like for months, and we can find a small subset of problems, we can transform them into a challenge. And after a few consideration, we finally can choose a few problem and make it become the challenge problem you see today. It's a harder process and takes a long time. For typically one challenge problem takes like half a year to make for a group of 10 people,
And then just 3 hours to solve for multiple groups of 3. Well, I would like to remind everyone that you, both spectators and future contestants, as well as ICPC contestants and coaches, will also have an opportunity to participate in ICPC Challenge Marathon that will be also held on Codeforces with the problem that will be based on this problem.
Yes.
We're not currently releasing any additional information about that, so you'll have to wait for the beginning of the marathon challenge to figure out what the difference will be and if there will be any difference. But there are some major prizes there, as well as a trip to the ICPC World Finals, Astana as a guest. So absolutely tune in. Because sometimes to achieve a good solution, you indeed need to read a few scientific papers and to figure out how it works. And 3 hours and no internet connection, well, may not be just the best way to solve this problem. Let's see if you will be able to beat the best result of 5,700 of our current first place Moscow Institute of Physics and Technology, or it works in a different manner. We see pretty close scores between problem A1 and problem A2.
Yeah.
Why do you think that is? Why is there no significant discrepancy between them?
I think that's a good sign because A1 is the open test set and A2 is a hidden test set. So Actually, the test cases distribution is very similar between the open test set and the hidden test set. So the score will be close. The only necessary we do not make all test sets being open is that we want to avoid our contestants by just optimizing their solution only for the test cases open to them. We want a more general solution, so they need to optimize for some hidden test case. That's why we have hidden test cases. And so we at the beginning we expect the score distribution of the A1 and A2 should be similar at the beginning.
Okay. Have you seen any of the solutions of our contestants today? Because
No.
they're uploading their solutions to the system, right?
Yeah, they uploaded, but we Huawei people still do not have the privacy to see the code for now. I think we can see the solution. I heard it's about like 1 week later we can see the solution, and I really look forward to see how the solution looks like.
How long do you think the solution of first place currently is? How much code do you need to write to get 5,700 points for this challenge?
I think from my experience, less than 2,000 online code. Less than 2,000 is just estimation, maybe shorter. I think that our consultant always did amazing stuff. So I was expecting to see something like this. And 2,000 line of code is already a huge amount, maybe less, I guess. But I do not think they can do something more than that in like less than 3 hours. It's a short period of time.
Oh,
for
right.
programming.
Very short. I sometimes saw people struggle with, classic competitive programming problems for a few hours in a row. I'm sure all of us, huge competitive programming fans, saw our team struggle during freeze time. So it's very easy to even not be able to solve a single problem over an hour period of time. And here, you need to solve a very complex problem in just 3 hours. By the way, we are over 2.5-hour mark, so we have just 22 minutes till the end of the contest. Do you expect any significant changes in the scoreboard at this point?
From my own experience, actually I'm come from Peking University and New York University. And
They're doing good.
Yeah, they're doing good. I'm Peking University alumni, and I say at the beginning of the contest they are all going to the first place, but now they are at the 6th place. So I hope they can get back to the first place. And the score difference is not very large. There are only like less than 20 score points difference to get back to the first place. I hope in the last 20 minutes they can make it come true.
We've already discussed that with Rafal, but a lot of contestants at these marathon-style competitions try to hide their real scores by adding a few edge cases that they know they fail with assertion, or probably just specifically not submitting their solution at all for a long period of time. Do you think we will see something like this in that contest? Are any of the favorites missing in your opinion? Do you think they're holding back?
I think that's a strategy to holding back their true solution, but I think from my experience, 5,700 is already a great score they can achieve. So I think at the top team, they are not hiding anything from my experience.
Cool. Are there any specific topics or maybe pre-written codes or approaches that you think can help coaches or those who participate with internet access over contestants who are very limited in whatever they have available?
I think the pre-written code cannot help much for this program because it's really hard and a classical problem. In my opinion, it's very classical and it's very hard. So, so I think for the coaches and for students are actually at the same line. because you cannot search on the web for solution actually.
Do you think there are enough, topics or at least areas of interest for 10 more years of ICPC Challenge at World Finals? Or do you think that we have a limited number of specific complex problems? Like scheduling is a very understandable complex problem that is well known in the world, and obviously like there are other categories that are still just as important. But do you think we have infinite number of complex challenge problems, or is it something that will that is fairly limited at this point?
I think it's infinity, and always there are some new topics comes out every year. So actually, Huawei is now a leading company in machine learning and computation, you know, and the large language model like ChatGPT just comes out in the last few years. And Huawei is all going to optimize their hardware and software to build more artificial intelligence. And you know, in the ICPC, and we do not have much challenge about machine learning yet, from my experience. But I think in the next few years there must be a few topics about it. And once there are a few problems about machine learning, like in the next 10 years, we can see some more interesting problem for some newer topic. Who knows? I think there are always new topics we can find.
Right. With machine learning problems, I think that there is always a challenge with such a short contest time that it's easy to write an algorithm that will be as effective as whatever you can teach as a machine learning model within 3 hours.
Yeah. That's a key problem that faces in the traditional ICPC challenge. You know, in 3 hours you cannot even train some simple neural network. So that will be quite hard for currently. But I believe the technology will evolve really fast, and maybe one day with the machine learning algorithm will run very fast. You can train a large language model on a PC in like less than 1 day, maybe. So maybe on one day we can figure out a way to get some machine learning challenges just like today.
Right.
But we need to find a way.
I already asked this question to Tomasz, but I think I'm very interested in your answer as well. Is there a programming language that would have given a significant advantage for our contestants but is not available yet?
For contestant but not developer, I think program language like C++ is quite gives them advantage because they add speed and they can implement some algorithm really fast because simplicity of the language. But for me, I believe the language is not the most important part of ICPC. The key part is the thought and the idea, the creativity you have. You need to solve the problem, and the language is just a tool. So the key is always your mind and your brain.
This is fun. I think that in general, I love seeing new tools being utilized to solve new problems. And obviously for our contestants, challenge is not just an opportunity to be exposed to this new type of problems, but also to try something that is out of their comfort zone, because they are very familiar with, you know, implementation and segment trees and clear algorithms. But here they have to think even more creatively than usual during the contest, which is very impressive.
Yeah, that's very impressive for me. During my experience, when I was an ICPC participant, I only know segment trees and like some graph algorithm. But when I come into Huawei and going to work, I know in real world there are way much more algorithm and data structure we can learn, because you know in ICPC most programs have only one correct answer, but in the real world there are a lot more choice. So you need to learn a lot when it comes to the real world.
Absolutely. We're 15 minutes before the end of the contest, so if you have any last dedication words or ideas for our spectators, I would be happy to give you an opportunity to talk to them.
I think so far so good. I do not have any idea to talk about it later. I think that's enough.
Okay.
Mm-hmm.
Okay. Thank you very much. Wonderful having you here. Thank you for the challenge, and see you all a little later. Bye-bye.
Bye.
I started with ICPC at high school. That's a good way to find friends. You share the same passion. Jan is my very good friend. We were in a team.
My name is Jan Tomaszewski. In 2019, me and Maciej won the CERC.
我是黄泽毅，2011年拿了亚洲赛的一个冠军。我是想说运气好。ICPC 的这个比赛其实对于我整个系统性的思维其实是起到一个重塑的作用。
I've been doing competitive programming for almost 10 years. ICPC helped me figure out my passion and helped me with career choices.
We learned a lot from ICPC, but someday the competition has got to end and we all need to transit to different things in life.
The most important thing I wanted from my job is to do something interesting.
And we were amazed about the multitude of things we can do here in Huawei. For example, our team works on algorithms and performance optimization. I wanted to have him in my team because he is a good programmer, good developer.
我是非常希望能够借助自己的算法编程，能够在行业里面去做出一番天地。如果你确实有意创新的想法，华为非常愿意支持这些新技术。
But at the workplace, it won't always be hunky-dory. There will always be problems that are difficult to tackle.
我印象中，围绕华为升腾芯片主打的一些算法，我们国内的团队其实已经苦恼了半个多月，做各式各样的一个调研，但是没有一个特别好的一个突破的一个方向。
大家有其他觉得这条路能走得通吗？能做实验吗？
But fortunately, there is always help around.
We were able to work with one another to tap on one another's strengths. There is one more person that really helps us, and this is our manager, Liang. I thought maybe this will translate, but it's not translated. He's helping with this task. He's making sure that we have everything we need to work on these tasks. He is always able to understand us. He wants to solve it as well as we want.
当我们一筹莫展的时候，东欧团队突然给我们抛了一篇理论，我也不知道该怎么用。深入去交流之后，给我的感觉是东欧的同事在幽暗的房间里凿出了一个小洞，透出了外面的光，让你一下子看到了希望。
30% improvement, and with some new algorithmic idea, and we plan on patenting it.
This actually proves that what you've done is really innovative, and it's not just some boring adaptation of someone else's work.
很少有公司像华为这么国际化的一个平台，让年轻的工程师能够接触到全世界各式各样的同行者，一起讨论、碰撞，去研究课题。这是一个非常难能可贵的一个机会。
Congratulations!
I went to Huawei. I can work on what I like to do and what I'm good at.
Bigger achievement.
I hope so.
Yeah.
In the future, I really want to be an expert in my field so that I can be successful in my career.
Maciek, please, let's carry on.
Thank you very much.
Thank you very
much.
Okay.
Move it to the future. I want to work on areas I'm interested in, and when I can have an impact.
也希望能够更多的跟其他国度的工程师一起去做一些系统级别的创新，去做一些真正有社会意义的一些事情。
And we are now at the last seconds of the competition, and it is now officially over. Congratulations to all the contestants. I think that's a great result. While we are having some final announcement.
I hear it was fun for the 47, but I don't hear any fun on the 46. Was there any fun on the 46? Oh yeah! Okay, so important notes. We will be announcing more after the dress rehearsal tomorrow. So please come to the dress rehearsal and be tuned because we have a lot of news to cover. Not only from that side, but also from this side. So you will see the frozen scoreboard, however, highly likely there have been a lot of changes. So tomorrow after the dress rehearsal, we will announce the winners and we will include the coaches as well. However, before we conclude, I have a couple of notes to make for the dress rehearsal. So first of all, you all need to wear your t-shirts and badges. And also, you probably noticed that in your backpack there was a hat. So please wear that hat for the procession of the dress rehearsal and also world finals. This is meant to protect you because there is a strong sun and you want to be in the best shape. Please note that there is no food, no drinks, no electronic devices during the dress rehearsal. Remember that you cannot add anything to your team materials tomorrow. However, we are aware of few late arrivals. So if you did not turn in your TRD, you must bring it to the team check-in tomorrow. Please keep it in mind. Second, if you did not have the opportunity to take your team photo with the trophy, today is your last chance. So please meet the ICPC photographers between 4:30 and 5:30 p.m. in the showcase area. Well, remember, there might be another chance. You win the World Finals. So please do so. However, I have a couple of more announcements to make. So the third one, please be on time for all the events that we have. In the unlikely event of not showing on time for the dress rehearsal, that might be difficult. Another announcement, there is a tech showcase open till 10 p.m. But at the same time, know that the buses are also available if you need to commute to the other hotel. And finally, before I let you go, we found a cell phone. So if you are missing a cell phone, there is one at the showcase at the DJ booth. So please come there. Thank you for your attention. I'm looking forward tomorrow to the dress rehearsal. It will be fun.
Final results will be announced tomorrow after dress rehearsal, as well as during awards ceremony after the World Finals. Stay tuned.